Okay, let's dive into the exciting realm of data with Python. Today, we'll explore SQLite and how to connect to it using Python. Databases are the backbone of modern applications and data analysis. As you've already explored, they offer us a structured way to store lots of different kinds of data in a robust fashion, offering convenience and performance. You may or may not have been introduced to SQLite 3. SQLite is a very simple database which is super easy to use. There's no configuration file required as the database is a single file. This means the database is portable. It doesn't require a special program to be set up to host the database, though you will need a way to access the data. It's versatile in that it has many of the features of a full-blown database like Microsoft SQL Server, Teradata, Oracle, or Postgres. There's a large community of support for the product. As a matter of fact, SQLite is likely one of the top 5 most deployed software modules anywhere. It's found on literally every Android device, iPhone, iOS device, every Mac, Windows 10, every Chrome, Firefox, and Safari web browser, many television sets and set-top boxes, and in many different automobile platforms. It makes a handy teaching tool because we can easily apply everything we learned about connecting to and making queries of a SQLite database to nearly every other major database engine. So, with that, let's dig in. We're going to look at getting data into and out of our database with 3 different methods. The first we call the classic or the SQL connection method. In this case, we create a database connection, construct our SQL query in text, and then we get back the result as a list of tuples. The second approach is to actually use pandas, our favorite data library, which allows us to work in data frames. In this approach, we construct our SQL query in text, and then we get back all the data at once in a handy data frame which has all the functionality we need to manipulate data in columns and in rows. A very familiar approach when we're dealing with data in Python. And third, we'll look at a more Pythonic, or probably the most Pythonic way to get data called object relational mapping. In this approach, we create a set of objects in our code which represent the entities in the database. In this way, we don't have to write traditional SQL code and instead focus on objects, letting the SQL Alchemy engine worry about how the Python classes map to database rows. We're going to take a brief look at all 3 approaches first with the pros and the cons. The classic approach to running SQL queries from code is simple. It uses built-in libraries and gives us the most flexible of all the methods. Since we're just sending SQL statements directly to the database, we can execute any statement that's supported by the database. The overhead is super low, we just need a database connection. It tends to be great for quick situations which don't require features provided by the other methods, or the overhead imposed by using pandas or SQL Alchemy. The biggest challenge to the classic approach is that since we are sending data, commands that are written in text, there's no support for debugging our queries. We capture this string representing the query and run it in another tool to debug. But if we miss a space, a parentheses, or misspell a parameter, this can be a real challenge to find among our Python code. One of the other challenges is that our data doesn't come back in a way that's very useful. Each row is returned as a tuple of values with no context as to the type or name of the column it's associated with. So we have to keep track of how we expected the data to get back out. With the pandas library, it's also very simple to set up. We just need to import the pandas library and set up the data connection the same way we would in the classic example. The upside to using pandas is that the data comes back to us in a familiar data ecosystem format, data frames, while we have the downside of having to write SQL code in text, just like in the classic example, we get the advantage of preserved data types and can move in and out of data frames very simply. So aside from the text-based queries, Panda brings a lot of overhead in terms of memory and CPU requirements to the table. Simple queries can gobble up memory and use more CPU than we wanted to allocate. SQL Alchemy is one of the most innovative ways to work with data in Python. Rather than using SQL commands constructed in text, instead, database entities are expressed in terms of Python classes. This means that there's no need to debug SQL statements from our code. Relationships between tables are abstracted away as lists of objects. There is no concern about memorizing the syntax for a single database vendor either. And this is important because while SQL is mostly the same, there are some nuances to the language. For instance, Microsoft SQL Server uses top as the keyword to limit the results, whereas SQLite uses a keyword limit. So if you need to switch between databases, this would require you searching through constructed strings to find all the occurrences and addressing each one in your Python code. But with great power comes great responsibility. The learning curve for an ORM can be difficult. There's a ton of setup required that can't be easily automated, and it can be difficult to get it exactly right. Once it is set up, though, queries are seamless and a delight. We'll have an exercise which exposes you to all three methods for querying the data. When considering which to use, I suggest to start with classic connections, especially if you need specific control over the database. If data manipulation is your primary concern, then consider pandas. Its data frame support will be familiar and offers strong structure. If you're building something more complex or the flexibility of an object relational model would be useful, then SQL Alchemy is your go-to.